Welcome to newsletter number 8, and this is a particularly long newsletter, and so I'm doing that thing which I kind of promised I wouldn't do. Firstly, going over time when it comes to these newsletters, and secondly, releasing it in my normal podcast feed. So, I'm violating my own laws here. Well, that's because it's been a busier than usual fortnight, and so the newsletter here is a little later than usual, and the next podcast is likewise running a little later than usual, somewhat delayed. But don't worry, we're getting back on track. That podcast to come is a technical one. Lots of science and heavy on the details. It's a reflection on the next set of readings from Chiara Marletto's book, The Science of Can and Can't, where I'm up to chapter 6, which is called Work and Heat. This is a chapter very specifically about a well-known area of physics, which is the subtopic called thermodynamics. Thermodynamics is a particularly interesting area of physics because within it we have something called the first law of thermodynamics, which is energy conservation, perhaps one of the first laws of physics learned by students in school. It is something most people are at least familiar with, even if they cannot provide a precise definition. But the fact is, most people have heard of the law, which is called energy conservation. But as Chiara and David say, that law is actually deeper than what other laws might be. And so it can be called a principle. It is something that other laws that exist, or even might be discovered in the future, must conform to. A purported law that violates energy conservation has its work cut out for it. And the fact is, it's likely refuted at that very first hurdle. Or in other words, if your newly discovered law violates the principle of conservation of energy, then that itself is a criticism of your law. And it remains a valid criticism, absent a good explanation of why the principle of energy conservation does not or should not hold. Now, the second law of thermodynamics is something else again. This law is a strange one in physics because no one knows how to derive it from anything more fundamental, as they tend to do with other laws. The history of science is kind of replete with this kind of thing. We have these things called, let's say, Kepler's laws, just as an example, and they govern planetary motion, approximately speaking. Now, without going into details about what Kepler's laws are, the fact is they were expressed by Johannes Kepler as 3 distinct laws in around 1619, which was about 6 decades before Isaac Newton published his universal law of gravitation. Now, the latter, the universal law of gravitation, is a deeper law. At least it was seen this way while classical physics still held sway. And from it, you can derive Kepler's laws, which are more emergent. There's like special cases of the application of the universal law of gravitation. And of course, now we have general relativity as our deepest theory of gravity, so we can make a few assumptions that might not strictly be true, but so far as approximations go, we can derive Newton's law, so-called law, of gravity, and hence Kepler's laws. Now, of course, truth be told, the word law here is a misnomer. If we're going to have the general theory of relativity, but Newton's law of gravity, we've got a bit of a problem. We just have to understand that the word law doesn't mean enshrined forever as the gospel truth. These are all misconceptions, remember, but that's a whole other topic we could easily get sidetracked by, and I'm not going to right now. My point here is that in theory, well, that's ambiguous. In principle, well, that's even worse. My point is that in science, when we find a deeper theory, we can show how the higher emergent laws or theories can be derived as approximations in some cases to a deeper law, or sometimes as laws that simply fall out as nothing but logical consequences of the deeper law. But the second law of thermodynamics is not like this, so far as we know, yet. The second law of thermodynamics cannot be derived from quantum theory. At least, we don't know how. The theory of how matter behaves in terms of what the particles are actually doing, such that there's an irreversible process, which is what the second law requires. The second law seems to give a so-called arrow of time, which some physicists are fond of talking about. Namely, the second law describes how things tend in this direction and not that direction, unlike with dynamical laws of motion or other dynamical laws of motion, or in terms of general relativity, which is laws governing space-time. The classic example is that we witness eggs smashing onto the floor once they're dropped, but never the pieces gathering themselves up again into a whole egg. Why can't quantum theory and general relativity explain this? There seems to be nothing in our account of time. For example, in the theory of space-time, which is general relativity, there is nothing in this theory that is able to explain why, in our real world, in terms of time, things tend to move in the direction of increased disorder, or the technical term is entropy, or towards broken eggs, rather than reformed once cracked eggs. Put it how you like. So the second law has always been this kind of empirical law, which is to say, we observe it to hold and never to be violated. But as to why exactly, we don't know. The second law is a statement of the break in symmetry between the past and the future. A symmetry that is inherent in all other physical laws. They are said to be reversible or time symmetric. The future resembles the past when it comes to dynamical laws of motion, whether these laws are classical or quantum. But the future does not resemble the past, as we know. Yesterday is not the same as today, and tomorrow will be different again. But why, in terms of physics at the fundamental level? We don't know. Something to do with the second law. But what exactly? What is happening with the particles that in all other circumstances are just obeying dynamical laws of motion that make no distinction between motion in this direction, that happens to be forward in time, and motion in that direction, which just so happens to be backward in time? Or put another way, if we watch some ensemble of particles interacting, let's keep it simple and make it just two particles crashing into each other. No physicist, or anyone else for that matter, who watched a movie of such a collision, such an interaction between two particles, presumably this would be a very high frame rate electron microscope super high resolution video of particles that are very massive, by the way, colliding. Neither the physicist nor anyone else would be able to say whether you had reversed the video or not. Is it running backwards or forwards? It may as well be forward in time as back in time. This is utterly unlike a video we take of a car crash or anything else in the macro world. But particle interactions? What is hiding in that thought experiment video that governs the tendency towards disorder or increasing entropy? Now, what Chiara has done, and what she explains in her book, is how constructor theory might be a new way of approaching the second law in terms of what is possible and not possible. So we'll be tackling that in the podcast, rather than me trying to explain it here right now. I think I've already said too much. My sense is that the podcast will stretch over at least 2 episodes, so I'll leave all of that talk for the podcast, which I assume will be out next week. Now, on to another topic almost entirely. One of my favourite politicians had something to say this week, which is a strange phrase for me to utter because I don't tend to have favourite politicians. Indeed, I have something between a healthy cynicism and a deep scepticism about all politicians as a working hypothesis. I'm kind of concerned about people who seek such a position because what they're seeking is power over their fellows. So long as they express great skepticism and have a good explanation of their skepticism about seeking power, then I'm more inclined to be favourable towards them. But there can be exceptions to this kind of cynicism about politicians in general. One would be, of course, Winston Churchill, because he was the right man at the right time that the free world and the Enlightenment needed to take power, to have power, and to wield that power at a time when the worst possible kinds of politicians had risen through the ranks elsewhere in the world. It's a shame this needs to be said these days, and presumably not to my audience here and now, but Churchill more than any other person should be the one credited with the defeat of German fascism, and hence Adolf Hitler and the Nazis. Or perhaps more precisely, I should say, won the Second World War in Europe and drove German fascism from power. I don't think European fascism was entirely destroyed, in truth, by any measure, but it was very much reduced in its potency and minimised or sidelined as a significant political force for some time, even if the underlying philosophies that drove it have persisted. But that's another matter. Churchill was also praised by Karl Popper as a philosopher, as an epistemologist in particular, and this is something I've mentioned before on ToKCast. And so, for that reason too, Churchill is near the top of my list. But as to living politicians, Well, there's no one in Australia to speak of that particularly impresses me, and right now we are almost at the end of the Australian federal election campaign, so we've had more than the usual number of political heads on screens talking at us. But in the UK, Daniel Hannon, ever since I first encountered him delivering a speech somewhere or other on YouTube, I think it was likely about Brexit, he's always struck me as being excellent. He speaks clearly, he answers questions directly, and he has a deep understanding of the relevant history, philosophy, and culture of liberty, wealth creation, the Enlightenment, and so on, all of that good stuff. He wrote a book called Inventing Freedom, which I really should add to the list of the books I discuss here. So I have almost nothing but praise for Lord Hannon of Kinclair, as he now is at the moment, being in the House of Lords. He's not shy about standing up to the excesses of the left side of politics and the right side of politics. He was correct, for example, to recently pen an article that was titled, "Why Are We So Afraid of Sex Differences in Education?" This is an important, relevant issue. The issue is basically that policy makers see it as a problem that boys choose physics more often than girls do, for example. Now, when I've worked in education, it was always seen as a problem for girls. Girls were supposed to choose physics more often than they did, and more engineering more often, and more mathematics more often. And the underlying assumption was that the reason they didn't was something to do with discrimination, or that vacuous term, unconscious bias. Now, the fact boys chose psychology and sociology and even artistic and dramatic subjects at a rate lower than girls was not seen to be particularly a problem for boys. And this way of talking, of course, feeds into universities. Universities have begun to actively discriminate on the basis of sex or gender when it comes to entrance into some courses. Girls are actively courted into the physical sciences in a way that boys are not, especially into physics. And all else being equal, if the number of places is limited, as they are, where two candidates for a position in a course are the same or almost the same on every other metric but differ by gender, well, the girl will get preferential treatment ahead of the boy. Now, very well. But the thing is, if all the obstacles are removed, all the inherent discrimination is gone, eliminated by removing such policies, such explicit policies, and even maybe certain behaviours that people might engage in, then humans should be allowed to freely choose rather than being cajoled into courses or provided carrots and sticks in order to rig the numbers so that they're closer and closer to 50-50. I think it's becoming increasingly well known, but it should be more widely known now, that in places that claim to be the least sexist, and on any reasonable metric are the least sexist, namely the Scandinavian countries, places where all the obstacles to girls entering whatever occupation they like are completely removed, the sex differences in job choice widens. It doesn't narrow. For example, there's a BBC article I'll link to in my Substack article all about this. The fact is that males choose this kind of area of study, this academic interest, and females choose that kind of area of study and that academic interest. But here's where, at this precise moment, when allowed to freely choose whatever they like, boys and girls, males and females, have these differences, this is where anyone who takes an interest in this seems to go wrong, no matter what side of politics they happen to be coming from. Some will see that fact, that there is this sex differences in academic interest between boys and girls, and go, aha, a moral problem. Even when the discrimination is removed, girls are still not freely choosing to become, for example, civil engineers at the same rate as boys are. Instead, they're choosing freely to become childcare workers. And this is a problem. So we need to incentivise women to make the correct political choice more often. Or at least the correct choice until half of all engineers are female. Or something like this. So that's one side of the debate. And on the other side, we have the people who say, aha, sex differences, a problem in need of a scientific explanation that we already have in hand. The science says male and female brains are differently structured and therefore boys like playing with trucks and girls like playing with dolls. Hence, they're going to have different preferences in terms of occupation, which is basically what's being said sometimes. Now, if we just accept it's a curiosity and we don't fully understand why this is going on, but it's not a moral problem that calls for us to react with policy to. A problem really is discrimination. But once that's been extracted out, once that problem of discriminating against people has been solved, why are we still concerned about the choices that people are making? Now, I'm going to sidestep the concern that anything like occupation or academic interest or subjects chosen in high school should be 50-50. We could equally look at the distribution of ethnicity versus interest in physics, or hair colour versus interest in physics, or body mass index versus interest in physics. I just don't think it's interesting, or that it matters. It's legitimate to ask the question, okay, it's not off limits in other words, but at the same time, the answer is of no consequence. So I think I would be with Daniel Hannon on all that. I think he'd be with me. However, on this issue, like some others that are related, Lord Hannon has become enamoured by evolutionary psychology and its close relatives, parts of neuroscience. Now I notice this because I'm a fan of his and I follow him on social media, so I tend to encounter the arguments he invokes that rest on the assumptions from evolutionary psychology. And the reason I bring it up is because I think his arguments stand. They're perfectly valid without the evolutionary psychology. More than that, not only do they stand without it, they are undermined by invoking them. Now, it's not just him, and he is in good company, so I'm focusing solely on the content of the ideas here. It could be anyone writing in this vein, and to some extent I can't blame a politician who's absolutely used to the idea that we take expert advice. Even one as switched on as Daniel Hannon on this topic, because it is the prevailing view in the scientific culture right now, wrong though it is. And that view is something like, the human brain is biologically adapted, and therefore the evolved physical structures of the brain determine, more or less strongly, the thoughts we tend to have. That's the theory. And those thoughts include things like the choices about what subjects to take in high school, which is a very strong claim. And in this particular case that Daniel Hannon wrote about, we're focusing on the differences in male and female brains rather than, say, the structures we share with chimpanzees or other primates, say, which is often what underpins some of the other evolutionary psychology stuff. And I'm going to completely ignore some important relevant science here, the same science that the evolutionary psychologists, or those who want to insert neuroscience into education, let's say, and that is there seems to be scientific studies out there that conclude there are no biological differences in anatomy when it comes to male and female brains anyway. A follower of mine from Japan helpfully linked to an article from Nature about this. Now, interesting as that is, it's utterly irrelevant to the deeper argument, which applies whether the brains of males and females are identical or even completely different in structure, because this is about function and what brains are and what they're functionally capable of, not about what they superficially appear to look like. Because if a brain has a functional capability, and one of those capabilities allows for people to freely make choices they do, then that's the important thing, given some culture. Now, some say on this point, when it comes to genetic determinism, the idea that genes determine your behaviour, or at least genes determine brain structure which determines your behaviour, well, it's not strictly determined in the way that the strength of gravity determines the rate at which objects fall to Earth, or it's not determined in the way that quantity of hydronium ions determines the pH of a solution, but it's something more like influence or shape, something like that. It's a little softer than strictly determined in the physics sense. Of course, we never know by how much the genes determine behaviour exactly, and most importantly of all, we do not know by what mechanism the evolved structure of the brain, or the DNA, determines or influences or shapes our thoughts. I'll say that again. We are never given a mechanism by which this DNA is able to influence our thoughts. How does it happen? Absent an explanation, we are in a world of non-explanatory science. Really, scientism. Science is the place we seek explanations. If there are differences between male and female behaviour or life choices that are said to be genetic in origin, then absent an explanation of how the genes determine behaviour, we aren't doing science. We're just guessing wildly. We are saying, here, grass cures the cold, just try it. But why? How? What's the mechanism? A hand-waving dismissal of, Well, it's clear there are differences between males and females genetically, so of course this is why the behaviour is different. That does not cut it. One may as well wave a hand dismissively to the heavens and say, well, there are literally hundreds of chemicals in grass. At least some of them will be hostile to the growth of cold viruses. That's just science. No, it's really not. Daniel Hannon has written and spoken a number of times about how we evolved on the African savannah and in places that were deprived of abundance. And for this reason, we tend to hoard stuff and we don't like free trade. See the Substack article for a link to that. So the argument goes, we've got genes for hoarding, and that determines our thoughts about capitalism. That's basically the case with some nuance. Now, I reject that, but not because of an irrational anti-science stance. Quite the opposite. I reject it because it's at odds with our best explanation on the topic, the deepest explanation of this. These are philosophical arguments, and people can be argued in and out of philosophical arguments. We're brought up to think a certain way about, for example, economics. Evolutionary psychology can claim whatever it likes, but if it wants to be science, it can't go around violating laws of physics. And it's claiming to. At least that's the case I'm going to be making. Or insofar as it is not claiming to violate physics, then it's vacuous. It just says genes determine stuff, but it doesn't say how. The deepest explanation that is relevant to this whole issue of male and female brains and our evolved brains and so on is known as computational universality. Now, the thing is this. People are minds. They're not brains, because the mind could be running on different kinds of brains. Their minds explain things. And this capacity to explain in a human being is universal. Now, this is another kind of universality I will come back to. But for now, let's just focus on the mind and say that the mind is controlling the behaviour of the person. That's what a mind does. The mind is not the brain in precisely the same way that the computer game is not the computer. The computer game runs on the computer, but the computer itself can do a literally infinite number of things, run a spreadsheet or a word processor or a computer game. It's universal, a universal computer. It can do all the things that a computer can do, in theory. Our brain, on the other hand, runs a mind, and the mind controls our behaviour, and we have a literally infinite number of behaviours we could engage in. Now, how does the mind control the behaviour of a person? Well, it does this by taking in some input, which basically means using one's senses to gather data, which to a Popperian, by the way, when we say gather data, includes also interpreting data. Now, the mind also controls behaviour, not only by taking in this data, but using this data to then make some decision. And to a Popperian, this means something like comparing that interpretation of our data to a theory we have guessed about the world, and then delivering the output, the behaviour. Now, it's no mistake that this way of describing things resembles what a computer sitting on your desk does, because it, after all, is taking in input, processing, and delivering some output. And this resembling, this is not because a human resembles a computer in some ways. It is because a person is a computer in some ways. And the way a person is a computer is that their brain is a physical system doing information processing. It's some hardware running some abstract creative program, some software. It is literally a computer. It's not an analogy. And the brain, like all physical systems, can be simulated by a universal computer. If we could simulate the action of the brain perfectly, then it would generate a mind. And I would go further, by the way, and say it would generate a conscious mind. I think these things are the same, but that's another story. And again, here is where many people, even many so-called rationalists, pull the brakes and cease, in my mind, being rational. They want to say something like, well, we don't know what consciousness is, therefore we do not know if consciousness comes along for the ride here when we simulate minds. But again, taking our theories seriously, even if we have a mystery as to precisely what consciousness is, it does not mean it, the phenomena that is consciousness, can just go around violating laws of physics. Or at least, that is not a good working hypothesis, that here's a thing, this entity that we know exists, consciousness, and which also doesn't comport to all the known laws of physics, as they're understood right now. That could be the case, but that could always be the case, about any mystery. Why not stick with what we do know and apply it to what we don't know and see how far that's going to get us? Let's see where that leads. And in this case, What we know is that the universality of computation applies to human brains, which are known to be conscious. And therefore, a simulation of such a brain will also be conscious because consciousness is known subjectively from the first person perspective and objectively because we can at least interrogate other people and they appear to be creative in the same way we are. So we assume it's a good working hypothesis that these other people are conscious as well, even if we can't directly observe consciousness, because what would that mean anyway? It's like trying to observe number in the abstract sense. Anyway, we know consciousness is known subjectively and objectively to be part of the output of functioning human brains, and therefore a simulation of a functioning human brain will simulate its output too, its conscious mind. It's rather like if we take a computer, let's call this computer B, and we simulate the behaviour of another computer, computer A. If computer B is doing the simulation of computer A perfectly, then computer B is doing everything computer A is. So if computer A is running a flight simulator, then computer B, which simulates computer A, must also, by definition, be running a flight simulator. So too with the human brain. If a human brain gives rise to a mind and consciousness, then if we take a computer and simulate the behaviour of the human brain, we will get a mind within it. Now, you might object to this. A lot of people do. You might emotionally feel this cannot be true. You might object that a person is more than this. You can stamp your feet as hard as you like. The thing is that this is what we know, fallibly, of course, as always, because of computational universality. It simply is the case that all physical systems are computable. They can be simulated by a universal computer. This is provable and has been proved. If the system obeys the laws of quantum theory, and anything made of matter does obey the laws of quantum theory, then a computer can be used to simulate the behaviour of that system, in principle. Now, I hasten to add, this does not make it that system. These things are not identical. A simulation of a bullet is not a bullet, as I have said before, but that is because a bullet is not computing anything. The central qualities of a bullet are all purely physical. They're not abstract. Unlike with, say, stuff that is abstract, like a song, which is abstract. It's a pattern. You can have the musical piece written down as a score. You can have it recorded as a video. It can be put on a CD or it can be played live. The song is not made of atoms. Stories are not made of atoms. Software is not made of atoms. Even though all these things can be represented in atoms, and in fact they need some sort of physical substrate in order for them to be represented there. But all of those things, stories, songs and software, they are patterns, particular patterns that can be represented in different physical substrates, and the human mind is one such kind of abstraction. It's a special kind, but it's of a kind with those sort of things, though different too. For now, it is only represented, as far as we know, in human brains. But there's also no law of physics that says it cannot be represented elsewhere, in other physical forms, just as songs and software can be. Because it is software. This happens to be the basis, by the way, of the argument for the possibility of artificial general intelligence. Artificial general intelligence, in other words, intelligence in silicon, computer intelligences, just like ours, but in a computer, have to be possible because we exist. We are general intelligence that exists. It takes a special kind of mysticism to assume that brains, our brains, wetware, or even human brains in particular, are made of a matter that is so special in its arrangement that it cannot be done elsewhere in precisely the same way using other matter. That's just an assertion. And it's at odds, once again, with computational universality, which says that whatever can be output by that system doing information processing over there can be done elsewhere by some other system, in principle. And the claim our brains are not processing information is just false. You can read this sometimes in certain articles. And it comes from this place that we want to assume we're special, but we are special. But we don't have to say we violate known laws of physics in order to be special. It's not a denigration of humans to say we obey the law of gravity, and that's why we can't just fly at will. Or that we need to eat because we must obey the law of conservation of energy, or the principle of conservation of energy. And likewise, it's no insult to say we obey the laws of quantum theory, and our brains must be computationally universal to do what they do, because they're computing stuff. They are computers, of a kind. Special, yes, but still, they obey the laws that apply to all other computers. A brain is a physical system. If you reject this, then you reject naturalism. You're in a world of mysticism and pseudoscience. You reject the notion that science, as we understand it, is the way in which we best understand the world. You are opting for a form of supernaturalism, at least in this domain. Or perhaps you think, well, that's what you think now, but tomorrow it might all turn out to be wrong. In which case, I agree with you. Of course, we can always be wrong. That's just fallibilism. As much can be said for anything, anywhere, anytime. You can't know Joe Biden as the President of the United States right now in 2022. Perhaps he just died and Kamala was sworn in secretly. You can't know that. Trivia nights would certainly be short affairs if all answers came down to, well, that might be wrong, if that was the standard. But we do know in the Popperian sense. Atomic theory might be wrong. Evolution by natural selection, the theory of tectonic plates, the theory of the inflationary Big Bang, everything we know could be wrong. To a Popperian, that goes without saying. But if we want to understand now, the best of what we understand now about people, then computational universality applies to people's brains as much as it applies to any other system out there in the universe. Now, on top of all of this, by the way, we have explanatory universality, and that means we can explain anything in principle. Once again, denying this just means some things are inexplicable by us, which is the standard retreat, by the way, of the religious mystic. Well, maybe you can't understand God, or why God caused the flood, or what the universe means in some sense, or whatever question you want to place off limits. Very well, it's hard to argue against those who deny humans can understand a particular thing. They're the pessimists. So long as they're not getting in the way of the people who say, no, we can solve that problem, we can explain and understand that thing, then I've got no issue. Of course, such people tend not to keep it to themselves. They do tend to get in the way. Religious people and supernaturalists do want to cordon off certain things, certain questions, and not permit them to ask these certain things or pursue that particular bit of knowledge because of who knows what. Supernaturalism, controlling policy, and so on and so forth. Now, what has that to do with anything? Well, the evolutionary psychologists claim that neuronal structure and inherited characteristics determine what thoughts we have. So hardware somehow determines software. But this just is not true for any other computer. Each year, the structure of the latest MacBook Pro changes a little bit, but its function doesn't. It goes a bit faster and it performs a bit better, but its essential repertoire of functions does not change. It can run all the same programs. It is still approximately universal. And indeed, it can run the same programs as any PC can, so long as the algorithm, the program has been written rather, if it's been coded. We should say that these computers can complete any task any other computer can, given enough time and memory. Human beings are all the same, in one sense. Mentally, what any human being can do, any other human being can do as well. So why don't we? And why is this so controversial? Well, it's a mixture of interest and time. Life is finite and people have interests to pursue. Sure, everyone kind of says they would love to be able to do what Arthur Benjamin can do. If you don't know who Arthur Benjamin is, he's a mathematician. He calls himself a mathemagician. He's worth looking up.
I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone I point to call out a 3-digit number. Anyone on our panel verify the answer. Just give some indication if it's right. A 3-digit number, sir, yes?
987.
987 squared is 974,169. Yes, good. Another 3-digit. Another 3-digit number, sir. 457 squared is 205,849. 205849.
Very few people can accomplish the amazing tasks he can, mentally. Is this just because they are mentally entirely incapable? No, they just lack interest. If they really, really were interested and tried really, really hard, they could learn the techniques. If they could, in particular, find out a way to make learning that particular thing fun, then they would. It's not genetics. There is nothing in Arthur Benjamin's DNA that codes for, let's say, squaring the number 1,462 in his head. I don't have that gene. He doesn't have that gene. So what makes the difference? He can do it. How? Because he's learned the technique. Is the technique in his DNA? No. There is DNA for building a particular brain structure, the human brain structure. Does his DNA code for a structure that allows for this? Yes. But then it codes for that in us as well, for anyone who can't do that particular thing, because that structure happens to be a universal computer running a universal explainer. In Arthur Benjamin's case, he used his universal brain to do a specific thing, namely become really good at a particular area of mathematics that almost everyone finds easy to understand as being impressive and is somewhat envious of if they can't do it. But the same is true of virtuoso chess players and pianists and trivia champions and so on. Human beings, people, have this wide variety of abilities because of the thing that does not vary between us, our universal minds. If we want to explain the differences between us, we have to explain that one thing we have in common, a mind that can do anything anyone else can. Our mind is genetically determined to do one thing, follow its own interests and explain the world around it, and as a consequence change those interests over time as we learn more in a completely unbounded way. A preference for mathematics and physics is not in the genes. It is not in boys' brains more than girls' brains. An ability to play piano is not to be found more in the DNA of people from that culture rather than this culture. There are differences when you go looking, absolutely. We don't know why they are all there. And is that really important, all these differences that exist between people ethnically and in terms of gender? What is important is understanding something far more deep than the superficial differences between people, even if those differences appear to be grouped according to gender and ethnicity, or whatever else. What is important is we are all people, and what a person is a universal explainer. And that is unique in the universe and explains why we have this variety that we do as a species. That's an amazing quality. And it is far more poorly understood than evolution is. And evolution is poorly understood. Our choices are not determined by evolution. That's an absurd notion. Our choices are literally choices. We choose freely because we, uniquely in the universe, create knowledge. Knowledge that wasn't there before only comes into existence because we exist. We are the cause of the knowledge coming into existence. We're creating knowledge in a way that nothing else, no other system we know of in the universe does. And so no matter what evolution has determined, evolution by natural selection, or rather what has evolved out there in the biological world, it is only through us we understand anything about any of this at all. And on understanding anything at all, we can choose to do anything, not prohibited by laws of physics about that thing. Genetics does not make some boys and some girls choose to do physics. Boys and girls choose to do physics because they really are making a choice. And left to choose, rather than being coerced or cajoled, and in some cases even guilted into it, which is a form of coercion, they will tend to choose this rather than that at different frequencies. Why? Because they exist in a culture and sometimes people react to them in a certain way, and none of this is a bad thing, so long as everyone is free to choose and is not being coerced. Now, there is an interesting postscript to all of this. The tweet from Daniel Hannon that prompted all of this basically linked to his article that I'm responding to here, but the tweet itself, well, it read, quote, "There are some aggregate differences between male and female brains. This is considered uncontroversial by neuroscientists, but unspeakable by politicians," end quote. Which, as we have seen, may or may not be true, by the way. Refer back to that Nature article I linked to earlier. But it's irrelevant for reasons of universality. And it was why I tweeted in response that, quote, well, I said, "What is correct about this argument is not helped by scientism. Brains are the wrong level of analysis. They're the hardware. We are minds, the software, which is universal. More males do physics, but not because their brains have a special structure. That's a red herring," end quote. And in response to this, David Deutsch himself remarked that, quote, "Universality, both computational and explanatory, presents severe problems for some rarely criticised institutions. For example, exams, poorly, measure something, but not underlying merit, so various corrections are applied. But given universality, what is underlying merit?" End quote. Which is quite right as well. We have this notion, whether school-based or university-based or the classic IQ test, we have this notion they're measuring something. In the case of the latter, the IQ test, I've long argued that the I should stand for interest and not intelligence. I think that an understanding of intelligence really is a binary thing. An entity can either create explanations, create explanatory knowledge, explicit explanatory knowledge, I should say, in which case it is intelligent, or it can't do that thing, in which case it's not. This matters for things like SETI, the search for extraterrestrial intelligence. Now, I've written a lot about intelligence and IQ tests previously, and have granted to the psychologists who endorse these kind of things that they are predictive, but they're not explanatory. And if a thing is solely predictive, but you don't know how or why it is, again, we're outside of science. We're doing something else. It's science in form only, and this is something that just plagues psychology as a discipline at times. IQ tests might very well measure, for some substantial number of people who take the tests, interest in responding accurately to IQ test questions. Look, if there's one thing I can tell you from my time as a teacher, there is a large, certainly non-zero number of people, students, who exist and who are very, very bright, switched on, but go into examinations and tests and any assessment at all and are utterly bored by the whole thing. They don't care. The exam does not capture their intelligence at all. It's capturing their interest in performing well in the test. I myself have taught students in mathematics who I have told my colleagues are absolutely brilliant in mathematics. And because I've seen it myself in the classroom. You know, young kids who do find mathematics exhilarating. I remember this one case of one girl. She was able to do prime factor decomposition, constructing factor trees. And she could do it in the blink of an eye with almost no upper bound on how big the number got. Well, not exactly, okay? She wasn't Arthur Benjamin type level, but she was a whiz at maths at like the age of 12 or something, at taking a large number and then being able to give you back the prime factors of that number very quickly. 29,250. A quick flurry of scribbles on the paper, and then she'd write down 2 times 3 squared times 5 cubed times 13. Now, as anyone who knows the technique, okay, so it's not that impressive. But this is after having just learned the technique at that age, and even for large numbers. Everyone could basically figure it out for small numbers, but she was doing it for large ones. But the thing is, this same student had absolutely no interest in doing tests. So she'd never perform well in tests, and for other teachers as well, because she spent a large time of each mathematics lesson doing her art. She was interested in sketching. Personally, I never minded, but this would upset other teachers, of course. So they would do things like send her to remedial mathematics classes and send her to remedial other classes. Because why? Because she wasn't performing well in tests, so therefore she needed help. But why wasn't she performing well in tests? Because she wasn't interested. She'd rather do her art, which is what I let her do as much as she wanted in mathematics lessons. And she ended up doing better in maths as a consequence. But my colleagues would always look at me quizzically when I said that this particular person, this girl, was astonishingly talented at mathematics. So was she or was she not? Well, I knew she was. But I also knew that no test would ever be able to testify to this. The test was a terrible tool. The girl was simply not interested in doing your test, or my test, or anyone else's test. She'd rush through any given test, write down a whole bunch of rubbish, and cover the blank pages in sketches and doodling. This is a creative intellect that the school was actively harming. And while I was responsible for her, sure, she had some reprieve from being told to do this or that or the other in a particular lesson, and perhaps find some fun now and again with something that was going on in the lesson. And that's how she ended up finding out that she liked this particular area of mathematics, of this prime decomposition stuff, so long as she wasn't heavily coerced into it. Anyways, examples like that and my own experience with IQ tests tell me that these things cannot possibly capture something like degree of intelligence. It's something else. Like in the case of IQ tests, on the occasion I have officially sat down and done one, and one of these occasions was when I went to an interview for my first ever job. I think it was like the second interview, actually. I went to a prior interview, and then I got through to the second round of interviews, and it was for being a security guard. And the head of human resources at the company, he was a psychology PhD, as it turned out. I think he was just finishing his PhD. Anyway, among other things, he tested everyone with a standard IQ test that went for about an hour. And I remember thinking as I went through solving the puzzles that, oh, this is fun. This is just like those other puzzles I do in books that I buy in magazines and newspapers I read, where I go to the puzzle page and I do that stuff. Try and figure out what shape doesn't belong, what happens when you rotate this one, which word belongs in this group or doesn't belong in that group, and so on and so forth. So I had fun, treating it like a game. But on the other hand, I also knew the feeling of eventually getting bored at some point. Now, what if you were bored? What if you had that feeling right at the beginning of the test? What if you were more nervous than what I was going into tests like that? Because at this point, I was very familiar with doing tests, but I can imagine that someone who's been out of school for quite a while, not used to doing tests, would be far more nervous. What if you're always bored and always nervous in those situations? Well, then the test cannot possibly be getting an accurate reading of your intelligence. It can be called an intelligence test, an IQ test, all day long, but that doesn't mean that that's what it's measuring. Even if it's predictive of, how well you're going to do in society and other occupations and how much money you're going to earn and all that sort of stuff. It especially won't capture how good a student like I was just talking about is going to do at particular tasks. But then here's a challenge. You want to hire someone and you need some criteria for hiring the person, and you've interviewed a whole bunch of candidates as much as you can, and you've looked at all their credentials. Well, credentials, there's another story in itself. Well, maybe you need a proxy for won't get bored easily by doing some mundane task, which actually is a pretty good trait to have as a security guard. Can you sit here for 1 hour and just focus on a single thing? So the IQ test might actually kind of get at that. Of course, you're focusing on an IQ test. Does that mean you can focus on security cameras or customers walking around a store? Well, I can personally tell you that no, it's not generalizable. I might be able to focus on the IQ test for an hour, but trust me, watching security cameras for an hour is a whole other story where it's far more easy to get distracted. So the IQ test isn't generalizable, even for that. But then what if you've got a limited number of places at your university for taking people into your chemistry degree course? How can we assess the candidate's interest in chemistry, even if we admit that we can't really measure intelligence in chemistry? Well, maybe past performance is some indicator of future commitment. Well, that kind of looks like induction, doesn't it? Unless, of course, we've got a good explanation why your past performance was good. But maybe that good explanation is that you were just pleasing mum and dad and your teachers. And so all previous high grades in chemistry in high school are just an outworking of that feeling of needing to live up to the standards of adults that you regarded as important in your life. And once that's taken away, say at university where you're a little bit more free, you're not going to perform so well. And worse, you were never interested that much in chemistry after all. You were just interested in completing chemistry tests to get good grades. I don't know if you remember that Simpsons episode where Lisa Simpson was really upset one time because all the teachers went on strike. And so Lisa turned up at her own teacher's house demanding to be graded. And so the teacher did grade her on some silly criteria. And when she was graded, Lisa reacted as if she was a drug addict who just received their hit of drugs. She was satisfied again for a certain amount of time, until such time as she needed to have that feeling of being graded highly again. So it's a real thing. I think there are absolutely people out there who love the dopamine hit, so to speak, of receiving high marks on tests. Never mind whether they're interested in the subject matter. They just like that feeling of being the top student in the class, getting the reward for doing so well from parents and teachers. But look, yeah, you might have a limited number of places in your chemistry course. You might have a spot that needs filling in your chemistry laboratory. Name a thing where you've got to make a judgment call about who's going to fill in this particular position. And if you admit, well, test scores are terribly flawed, but I've spoken to 15 people, all of whom could fill in this position, and I can't split them, except on grades. Well, what do I do? Well, I don't know. I've got no good answer to that, except that if time is a factor in your life and you need to explain this decision to someone with, let's say, well, they've got the final say, better grades is better than anything else, absent everything else. Or higher IQ scores is, absent everything else. But are we really in a position where it is absent everything else? I don't know. It depends. But we can admit all of that imperfection and never admit that actually intelligence is a sliding scale. And we might also go even further and say, actually, performing well on some examination might actually indicate precisely something of the opposite quality to what we want. Namely, high test scores might indicate a very high knowledge about how to meet predefined outcomes and how to learn pre-existing knowledge. And it might also simultaneously indicate a poor ability to question any of that pre-existing knowledge, to think outside of the box and really make progress creatively. It could mean all of that. But for every urban legend of the genius scientist who failed high school, we've got other examples of genius scientists who also top their classes across the board in every test. So there's that as well. What to do about tests and exams? I don't know. Clearly we must move away from all of that in school. But that's just a special case of we must move away from coercion when it comes to learning of any kind. Forced to attend lessons, forced to undergo assessment, forced to turn up at a particular time and listen to a particular person give answers to questions never asked, well, it's all got to go. And here on this side of the ledger, that anti-coercion side, it can be 2 steps forward and 1 step back at times. But that does mean we're making progress, we are moving forward, and incremental dismantling of a terrible system is somewhat more palatable to the powers that be than saying something like, well, in the words of the proverbial fire sale spruiker, everything has got to go. Okay, that's enough for now. Until next time, bye-bye.